Bismillah ar-Rahman ar-Rahim. For now, we can, for example, export our as having our model trained and having everything done. Now we can go to our neural network tool or window and then export. We will export only the output and the errors and M1. PT1 and PT2 is already exported, and we will export, choose them, then we'll export them. We'll have them here in this, in the workspace. These are the errors, which are the difference between the predicted and the observed, and these are the predicted values. So this is our observed and this is predicted values. This is predicted and this is observed. PT is observed and the output of our model is the predicted. Of course, we can take these, let's say, by the way, I'm using my own way to export and import, and of course, not only in MATLAB, in every programming language or programming software, let's say, like R or MATLAB or Python or whatever, you can have your own you can have several ways of importing or exporting, saving, whatever. In this case, I'm using my own way. So I just copy and paste it. I will insert something again. I will say this is, well, let me just transpose them to have them as a column. Have them as a column, pardon. Wait. A minute. Distribution transpose. Okay. I will delete this one. Let's say this is, I will say this is observed. And then I will predict, I will bring the predicted or the outputs of our model. I do say again, it is my own way to import and export data. Of course, for this example, in general, I use what I call it the programming, the code for importing and exporting. So it is your choice. The paste special. Pardon. I have to paste it, and then I'll cut, and then pardon. Which is something like, of course, it has some issues because importing from another software. It's okay. No, it's okay. Let's just do this. So it's okay. Now we have our observed, and these are predicted or estimated from the model. Now we can calculate, for example, R square and RMSE. To calculate this, I will go to, this is the RMSE, and this is the R square. Well, I will put them side by side. So let's start with RMSE. RMSE needs the difference between, this is the estimated, this is the estimated values, and this is, or the predicted, pardon, and this is the observed. So First of all, we are taking the difference between them and square and then divide by n and then taking the square root. So I will do this step by step. First of all, we'll take the difference between the predicted minus the observed, and this is only the difference. I would say here it is a difference, and do this for all the things. This is the difference, and then we will square it. So let's call this one, this is the error, and this is the square of the error, the square of the error. Let's call this one after 2. So this is the square, and then we are going to sum this squares, and the sum is going to be here. This is the sum of square of error is equal to sum of this. These are sum of square error, and then we will do the sequence when we will divide it by the number of the values observed or predicted, so we will call it the average of SSA, and that equal to this one, this divided by 1, 2, 3, which is 123 values that we have, and then we will take the RMSE. So our RMSE is just the square root, SQ, I think is only the square root of the average of the sum of the square of the errors. So this is RMSE, and by the way, it's important to say that this is a unit value evaluation criteria and not unitless. R square is a unitless, but RMSE is a unit. It has its own unit. It takes the unit of the observed data. For example, pressure. If you are measuring pressure in Pascal, for example, the unit of RMSE is going to be in Pascal, but R square is unitless. Therefore, RMSE can be used, cannot be used for comparing between two studies, but predicting for two studies as done for predicting the pressure. RMSE cannot be used because it depends on the number of the values and the number of the observed data, and all these things are affecting the RMSE value, and it is unit. It has its own unit. But R square can be used as is a unitless, can be used. That's why R square was developed in order to be used for comparing two studies or two data sets, two different data sets, but RMSE cannot be used. So this is our RMSE. As can be seen here, RMSE is small, and I want to remind here, our data is normalized data, which is between 0 and 1. Our data is normalized as here, I see here. Our data is normalized, so normalized between 0 and 1. Of course, normalization can be done with other values, but in this case, our data normalized between 0 and 1. Therefore, RMSE is not, it's not that much, not too big, but that's why R square is an important indicator for the performance of the model. So coming to R square has the dominator and nominator. For example, the dominator is similar to the denominator of RMSE. So therefore, we are going to use it. We are going to use it as it is, which is SSE, the sum of the square of the error. But in this case, we have to take the difference between the observed and the mean of the observed data. So first of all, we are taking the mean. Let's get the mean of the observed. The mean. This is the average. Like the average or the mean of the observed data can be get. We'll get it here from the average. This is the mean. Then in this, I'll name it as a what we call it. How we call it? This is the total variance, pardon, or the, let's say the total error or total error. This is the total error, which is this one. So this one is equal to observed data minus the average. I will do the whole thing here in order to have the I'll do the saying it's equal to I'll open a bracket. I'll take the square of them directly. This one minus mean, then close the bracket up to 2, and this is the square of the difference between the observed data and the mean. So we will sum them also, equal to sum, prepare the denominator, so this is the sum, now say sum of total error I will have some differentiation. This is so this is the unit, this is the ST. Then we'll have the R square, and it is equal to 1 minus, open the bracket, point, or this divided by the sum of the square error divided by the total error, and this is our R square for the whole data, 0.969, which can be considered 0.97, which is very high. That means our data or our model, let's go to our model. This is the first model, has an R square, pardon, has an R square equal to this one. So this is the R square equal to, I'll take only the value for having values. This is my R square for the first model. So I'll consider only, now we have already done the first model. We will go to the second model in the same video for having all of them combined in one video for easier referencing. So I will go to MATLAB. Before that, let's go to and check what is our model. Our second model is prediction or estimating of P pressure at the current time using PT minus 1 and PT minus 2, not only PT minus 1 as in the first model. So coming to MATLAB, we will use these two as an input, PT minus 1 and PT minus 2 as an inputs and PT as a target, and do the same steps. So go to MATLAB, and then we will have, let's remove this, which is our model outputs. So this is our input. Now, in order to have this as these two, pt minus 1 and pt minus 2 as an input, we have to combine them in one matrix in MATLAB in order to consider them, in order to be considered by any tool as one input. So let's have it. Let's have them together. First of all, we have to do to PT2 what we have done, what we did to PT1 in the previous steps, which is removing the non values, which can be done if we open it by double click or whatever. First of all, we have to transpose the PT2 equal to PT2 dash, and then we will have PT2, and we will remove the first value as it is a non value. None is removed, and also 1 to 4 as we haven't considered this in this, or we haven't considered this, pardon, in this case in pt minus 2 we don't have none values, as we haven't removed when we prepared our data. Here, if you look at our data, we can see that in pt minus 2 we don't have none values, but when we import in pt minus 1 and pt minus 2 and pt, we have two empty values, and here when one empty values. But in either cases, we have to have the same number of observations. Therefore, we have to remove these two values from pt minus 2 in order to have the same number of values with the same number of values with the pt. So if we look at pt, we have from 1 to 123 or 123, but in pt2 we have 1 to 125. So we are going to remove the two last values, pt from 1 to 3, part 1 to 4 to 1 to 5, remove them. So they are removed, and now we have the same number of observations. In this case, after this, we have to combine pt1 and pt2 to have one matrix as an input. And this, let's call it input equal to pt1 and pt and pt2. We can put semicolon here for having not. So this is our input. We have now 1 and 2, as I said earlier. In ANN, every row is considered as one variable, and every column is considered as an observation. So we will add these to, now we will go to our NN tool and put them as an input, NN tool, and we will have everything deleted, or we close them, and we'll have NN tool again for having everything clear and new. Now import from MATLAB workspace, we will have input as input data, then import, and target as pt as target, import, and OK. So we have input and target. Then create our network, and we will call it M2. Input, select the input data as input and the target as target, and we will give this, and also we'll use C, and we can see this is two inputs. Now we have two inputs, not only one, pt minus 1 and pt minus 2, and one output, which is pt, and create. We'll click create, to have our network created. Okay, then open them, open the network, then go to train, choosing the inputs, target, and these train parameters, as I said earlier, can be changed and can be modified according to our criteria, but in this case we are not using it. So you will training the network, and the network is trained, and we can see the performance, and this is the best validation, which is not for not having overtraining. After this point we have overtraining, so therefore it stopped at this point, and we are using this point at 3 epochs. And then we have the regression. This is the regression, and can be seen correlation has been improved, correlation, but we are not going to use correlation. We are going to use our and you can see also, of course, the fitting between the output and the target, the observed and predicted data. They are fitting to each other. So this is our regression. We will close these windows and go to our network window and export our output. Export our output. Let's have only the output and export it. These are the predicted data using the model, and copy them. We will copy this as our observed data is already copied to our Excel file, but in this case we are taking only the second model predicted data and bringing them to our prepared Excel file and paste them, then we'll take copy of them and paste them as a transpose. So now everything is changed, and we should have our R square, which is here, and our R square, as can be seen, has been improved for the second model, as we have added another lag, which is PT minus 2. So this is the whole idea, and now for the model number 3 we can also use HD as for combination, another combination for model number 3. But in these 2 videos I have already told you the whole idea and how it works, how we get the lag for PT or for HD, and whatever the variable do you have, and also how to prepare this data in Excel file and then train them by using any tool in MATLAB, and then after that we can use also we took them to the output and the observed into Excel file and calculate the RMSE and calculating the R square, and another important thing I need to remind here is R square used for comparison as it's unitless, but RMSE is a unit. It has its own unit, but and also it is important to remind that in this case we are using the normalized data, not the observed data itself, but the normalized data, which is only normalization. So far I think this is enough. For other models, M3, M4, or whatever the combination that you need, you can follow the same steps and take and extract the R square or RMSE. So thank you very much, and we are going to explain multivariate linear regression in another video, of course, and also by using MATLAB. Thank you very much, and see you in the next video.